All right, so I'm going to go through these slides again. I'm going to give like the highlights and go through the quick version and point out a couple of things that, even though they're the same slides that we already looked at in class, maybe this video will help bring out a couple of things that you missed in class, or just there's so much information in class that maybe you were having a hard time trying to get the high points and the most important things. So let me go through these pretty quickly. Before I go through the actual slides, I want to look at the warm-up that we did in class. In this warm-up, I gave 4 different patterns, 3 and 4 patterns. And like you can see, this one we have 2, 6, 10, 14. Over here, I'm not going to erase this writing here and here. That's from class, but we'll just leave it there. But you can see all different types of patterns. And what I had everybody do was they first had to identify the pattern. So if we just look at this first one, we go from 4 to 6, so that's plus 4, plus 4. We're adding 4 every time. So first we identified the pattern. Then I said give the next 3 terms in this pattern. So here if we add 4, we'd have 18, 22, and then 26. So the next 3 terms. Now the part that we struggled with and talked a lot through together was how would we write an equation that represents this pattern. We know that, or we're most familiar with equations in this form, y equals mx plus b. So how do we write an equation that represents that, so that I can give you an x value? For example, I could give you 4 and I would get 14. So that was our challenge at the end of the warm-up. Now if we start to write our equation, our slope, we can see pretty quickly our slope is 4, that we're changing by 4 every time. A lot of people naturally said, oh, your y-intercept has to be 2. But then when we plugged 4 in for x to see if we would get 14 here, we had, we had 4 times 4 for the 4th term, plus 2. 4 times 4 is 16, plus 2 is 18. So we actually got the next term when we tried that. So what we struggled through and tried to figure out was, all right, how do we write an equation that represents these patterns? And really that process that we just worked through is exactly what we learned in this lesson. Is they're going to give us a pattern, and they're going to give us a way to write an equation of that pattern. Now we're going to use some fancier terms and different things like that as we do it, but that's the main gist of what we're looking at here. So instead of calling these all patterns, each of these is called a sequence. So up here we had 4 sequences. Each one of these was a sequence. And the technical definition of a sequence is that it's just an ordered number or ordered list of numbers. So the order means that it's consistently going up or down by the same amount. Plus 4 every time, minus 6 every time, plus 2, whatever it might be. Now each term, or we have terms, and we would say that a term is each number in the sequence. So if we have, this is the first term, second term, and so on. Now like up here, if we just took these right here, 2, 6, 10, 14, we would say that is a 4-term sequence. Here, you can say that it goes to this a sub nth term. That means that this sequence goes on forever and ever. So there's an infinite number of terms, and that's what this a sub n, or the nth position. We would say that 5 is in the first position, second position, third position, fourth position, and so on. So a little bit better vocab for the patterns that we're looking at. Now, like we said, this is called an arithmetic sequence, meaning we are adding by the same thing or subtracting by the same thing. The common difference is what we are adding or subtracting by. So again, better vocab. Write the next 3 terms. That just means continue the pattern. So these are consistently subtracting 7. So if we write the next 3 terms, we would continue to subtract 7 every time. I'm not going to go through graphing these necessarily. Well, I will really quickly. I'm not going to actually draw the graph, but when we look to graph something like this, we have this sequence. And what we want to think about it as when we graph it is that 4 is our first term, or it's in the first position. So we would write that as an xy with 1 as our x because it's in the first position and 4 as our y. So then we would have 2, 8, 3, 12, and 4, 16. And I know that you guys know how to graph, so I'm not going to go through and graph. But what you would notice is that it forms a line. And this should not be a surprise to you at all, because when we looked at this sequence up here, we noticed that it was going up by 4 every time. So it had a slope of 4. So of course it forms a line. That should not be a surprise to us. Now here's where things can get a little tricky, is writing equations. We tried to write an equation on our own really quickly in the warm-up, and we were a little bit off. So here is the formula that we use to write an equation. A sub n, or whatever term we want, can be found by putting a sub 1 plus n minus 1 times d. So if we take our pattern from earlier, it was 2, 6. Whoa, no. 1b here. 2, 6, 10, 14. If we take our sequence from earlier, our first term would be 2. N is what we leave in as a variable. And d is our common difference. So we knew that these were going up 4 every time. So we would go times 4. Now, this equation is not in simplest form yet, but before we get it in simplest form, we have n as a variable and a sub n is what it's equal to. All this means is that I could tell you, I want you to find the 156th term, or what number will be in our pattern after our pattern happens 156 times. So we would take 156, plug it in for n, and whatever this spits out would be the number that represents 156th term. It'd be the number in the 156th position. But again, we're not in simplest form yet. So let's get in simplest form first. Back, 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 back. Good. Simplest form. We're going to write it in a form that looks just like slope-intercept form. So in order to do that, we need to get rid of these parentheses. So that would mean that we need to distribute this 4. So 2 plus 4n minus 4. Now we simplify. We get 4n minus 2. Now that we're in simplest form, this would be the way that I would expect an answer on a test or on a quiz or anything like that. Now we could still, if we wanted the 156th term, we could plug 156 in for n, and then we could solve. That's going to be like 622 or something like that. So if this would mean if 622 is right, then that would mean that after we repeat this pattern, 2, 4, or 2, 6, 10, 14, if we repeat 156 times, that term will be 622. All we needed to do to find that is we take our pattern, or we take our equation here. We take our equation, we plug our first term in for a sub 1. We plug our common difference in for d. And then we look to simplify it like we did right here so that it is in slope-intercept form. Now, it's not called slope-intercept form because we're dealing with sequences and we're dealing with patterns. But we know that that looks exactly like and acts exactly like slope-intercept form. All right, I'm not going to go through this example because we just did an example here. What you look at and find in this example, and if you want to look through this, I can clean it up a little bit. But if you do want to look through this on your own, like pause the video, you could do that. But what you'll see in this example is that our common difference is a -3, which is totally fine. I mean, we can be subtracting from our terms every time. Also in this example, they say, all right, now find a sub 50 or find the 50th term. So you can check out how we would solve that.